Hi, my name is Maddie, and I'm going to talk to you a little bit about conductive heat transfer through a furnace wall. Conduction is heat transfer through a stationary medium, most commonly a solid. The driving force behind it is a linear temperature difference, as you can see in the governing equation, which shows that the heat flux is equal to the thermal conductivity of the medium times the temperature difference over the thickness of the wall. Assumptions that go into this governing equation include that the thermal conductivity of the medium does not change with a change in temperature, and the medium material for the wall is uniform throughout. When you look at conduction through multiple materials, the heat flux is the same through all of the materials, and so using that assumption, you can create the equation shown that the heat flux is equal to the overall temperature difference over the sum of the thickness of each respective material over its thermal conductivity. This is an example of conductive heat loss through a furnace wall. If you have a furnace wall that's made up of a layer of cow wool on the inside and a layer of carbon steel on the outside, and you measure the temperature on the inside of the furnace and on the outside of the furnace, and you're given the furnace dimensions, you can find the heat loss through the furnace walls. To do this, you need to look up the thermal conductivity of each material. The John Zink Combustion Handbook is a handy tool for this. There are also literature values published in many other textbooks and journals. For heat flux, since it's heat transfer over area, you can assume that the area for each material is just 1, and you use the equation from the previous slide of the temperature differences and the thicknesses and thermal conductivities, and you can find that the heat flux is 30 BTUs per hour foot squared. Now, to find the heat loss, you need to find the surface area. So using the furnace dimensions, you can find the surface area, and if you multiply the heat flux times the surface area, then you get 0.75 MMBTU per hour heat loss. And using this value, you can estimate your monetary losses if you have a $1 per MMBTU value for the fuel that you're using to heat the furnace.